Ball is thrown upward. Initial velocity of 18 meters per second. The height of the ball is modeled by the equation h of t is equal to 18t minus 4.9 t squared. And we're measuring meters. We're measuring in seconds. Now, as you look at it, just kind of a physics note for you. Anytime you have an object thrown into the air and it's in meters, it will always be negative 4.9 t squared. That's because the acceleration of gravity actually happens to be negative 9.8 meters per second squared. The initial velocity will always go in front of the linear term, and the initial height will always be at the end. Okay, so in case you're wondering. Maximum height that the ball reached is our question for the day. So you got an object, you're tossing in the air, you're wondering the maximum height. We're going to try to use calculus in order to make sure that works out. So you tell me something about the velocity on the way up. It's positive. Velocity on the way down. So as I cross from positive to negative, I have to cross over what? 0. So would you agree that it will reach the maximum at the time at which, Sarah, it will reach the maximum at the time which the velocity is equal to 0. So what is the velocity function? So we're wondering, where is that equal to 0? So 9.8t is equal to 18. Divide by 9.8. Somebody tell me t is equal to what? Go away, Miss Nelson. There we go. All right. What do I get? 1 point what? 84. Okay, very good. So now it says, what is the height of the ball after 2 seconds? But I still haven't answered my initial question, which is this: the maximum height of the ball. I know the time at which it reaches the maximum height, but I don't yet know the maximum height. How would I find the maximum height? Plug t back into what? The original, because the original tells me the position. So 18 times 1.84 minus 4.9 times 1.84 squared. We get 16. So 16.53 feet, that is the maximum height. Next question, what is the height of the ball after 2 seconds? I'd plug 2 into what? Velocity or position? Position. H of 2 is equal to 18 times 2 minus 4.9 times 2 squared. $16.4. What is the velocity of the ball after 2 seconds? How would I compute that? So 18 minus 9.8 times 2. Oh, thank you. Working in meters. Negative 1.6 meters per second. And at what time does the ball have a height of 20 meters? Never. Why? Yeah. The highest is 16.53. 16.53. We took the time and we plugged it back into the original. No. That will be acceleration. Okay. Now, hold on. Okay, you guys were all able to say that it's never going to be equal to 20 meters. But what about 10? Will be equal to 10 at some time? So how will I figure out where it's equal to 10? 10 is equal to 18t minus 4.9 t squared. When will it reach a height of 10? How do I calculate that? Yes, so I'll put it on the other side. 4.9 t squared minus 18t plus 10 is equal to 0. What are you going to use? Quadratic formula. What do you got? Somebody type in to your quadratic formula 4.9, negative 18, and positive 10. Give me your two time values. .99 and 0.68. Any questions on that? So today you want to investigate problems that have to do with motion of objects, kind of build off of yesterday. Think about velocity. Think about when you plug into velocity, when you plug into position. Maximum height is when the object has a velocity equal to 0. Yep. All right, flip it over to the economics application. Yes. Once on the way up, once on the way down. All right, economics application, cost function. C of x. Marginal cost, we're going to call C prime of x. Here's the idea. I'm going to make shoes. Would it cost me to make shoes for Allie? They're broken. All right. Yes. So as we make shoes for Allie, okay, what if I was a shoe company, is it going to cost me more to make one set of shoes or 1,000 set of shoes? 1,000 sets, right? But will I be more efficient at making one set or at making 1,000 sets? 1,000, yeah. In fact, I will hopefully it will cost me less to produce that 1,000 shoe than it would that very first shoe. And that's what we're trying to figure out here with marginal cost function. The marginal cost function is approximately the cost of producing the next item. So for example, suppose it costs me $20 to produce the first pair of shoes. Hopefully, the cost of producing the 1,000 first pair of shoes is maybe around, say, 12 bucks. Hopefully, I've lowered my marginal cost. So, company produces X number of shoes. Cost can be estimated by the following function. Right here. What is the marginal cost function? What would I do? Derivative, C prime of X is equal to what? So, what is C prime of 500? How would I figure that out? Plug it in. And C prime of 500 is going to be equal to 5 plus 0.02 times 500. Which somebody already calculated is $15 per shoe. Somebody showed out 15 already. So Jonah did. So the question is, interpret what C prime of 500 means. No. Here's the things it does not mean. It costs us $15 to produce each pair of shoes. That's not what it means. And it does not mean that the average cost has been $15. At 500 shoes, or C prime 500 means the cost of producing the 501st pair of shoes is approximately $15. That's for B. The cost, if we typed in the cost of producing 500 shoes, is $15,000. But hopefully we become very efficient with it and lowered our cost to $15 per pair of shoe. So now I'm going to compare C prime of 500, which is $15, with the actual cost of producing the 501st item. In order to figure out how much it cost me to produce that 501st item, I'm going to figure out what is the cost of producing 501 items and subtract the cost of producing 500 items. That will tell me how much it costs to produce that 501st one. So I'm going to figure that out. We do 10,000 plus 5 times 501 plus 0.001 times 501 squared. Oh, it's just 0.01. Okay. And I'm going to subtract 10,000 plus 5 times 500 plus 0.01 times 500 squared. Are we close? Yeah, we are close. And you might wonder, why aren't they the same? And the reason why is because, you know, the next item is a whole unit away. C prime tells us the instantaneous rate of change right at 500. But the fact is, we'd step up a whole integer value to produce shoes. So your assignment will be on the board when you get back, and I'm stopping the video. There's your assignment.